Hi guys! For this video, ang pag-uusapan naman natin is all about the three-moment equation, no? So, for me, personally, one of the most important formulas in structural theory is three-moment equation because kahit gaano pa karami yung span ng mga continuous beam, napaka-effective nitong equation na to perform structural analysis. Okay, no? So this equation is used mostly intended for yun na nga continuous beam kasi nga napaka powerful nito. Okay? So let's discuss the general formula of the three-moment equation. So if we consider a span ABC as shown below, so the general formula of the three-moment equation is this. So ito yung talagang original formula while I will present three formula later, but those are just special cases based from this formula. Okay, no? So here we have MAL1 all over EI1 plus 2MB over L1 over EI1 plus L2 over EI2 plus MCL2 over EI2 plus 6AAB centroid A over L1 all over EI1 plus 6ABC centroid C over L2 all over EI2 is equal to 6 the quantity HA over L1 plus HC over L2. So I will just explain this entire formula, no? So the three-moment equation is good for a span with three moments. So katulad nito, moment at A, moment at B, and moment at C. So there will be a discussion of the sign convention. But the discussion of that is siguro later on na lang once we present the solution. But anyway, yun na nga, may mga values itong MA, MB, and MC. Tapos, yung span from A to B, we call this as L1. And yung span from B to C is L2. Yung vertical deviation ni A and B, tatawagin natin yan ang H1. And the vertical deviation from B to C is H2. Okay? So, of course, ang mangyayari, yung M1, yung MA, imumultiply mo ng L1, then divide ng flexural rigidity ng AB. So, assuming kasi na yung flexural rigidity from AB is different that to BC. Okay? Then, plus 2MB, since dito yung MB, the middle of the 3 points. So, ang mnemonics ko dyan, dahil nasa gitna siya, or dahil yung B is nasa gitna, I will just write is as 2. 'Di ba? So, tapos, yun na nga, L1 over EI1, then L2 over EI2. And of course, MC, L2 over EI2, then plus 6AB, centroid ng A over L1, all over EI1, tapos 6ABC, centroid ng C over L2, then EI2. So, itong mga values nito, we will discuss this later on this video. Basta, actually, ito yung pinaka-complicated sa discussion natin, yung maghahanap ng values na ito. The old-fashioned method is to use the tables na kung makikita nyo sa libro ni Lucky Pytel and Singer in the Strand of Materials, there are tables para sa mga uniform beam, uniformly varying, concentrated, so on and so forth. But I will not use those tables because I want my discussion to be versatile. Okay? So, ang importante, itong mga values na ito can be obtained later on. Parang may specific formula ito katulad ni fixed and moment kanina, no? But ang importanteng tandaan ninyo, itong constant na to, this is a constant itong nasa taas. Itong constant na to is with respect siya sa span AB. Tapos, yung centroid is with respect dito sa A, to the leftmost end. Okay? Always to the leftmost end. On the other hand, ito naman, 6ABC, centroid at C, the rightmost end. EI and E2, of course, is the flexural rigidity of AB and BC respectively. So that is equal to 6, the quantity HA over L1. So, I mean, ang HA dyan, itong H1. Okay? I just have a typographical error. So, HA is simply, siguro tawagin na lang natin siyang H1. Then, ito, H2. And here, H1 and H2, they are both positive, no? Because ang reference natin, yung point A ba is nasa taas or nasa baba ng point B. So, magiging reference mo is yung point B. If the points are above the middle point, so you need to take note that H1 and H2 are positive. Okay? So, halimbawa nga, itong nakikita nyo sa figure nyo. So, it is evident na these 2 points are above point B. Okay? But of course, again, in the analysis of the continuous beam, hindi naman natin masyadong gagamitin itong a special formula na to. Because, yun na nga, there are, sorry, no, itong general formula. Because, of course, in the analysis of continuous beam, mas simple siya compared to the general. For instance, most likely, yung tatlong points will be leveled. Okay, so kung leveled sila, ibig sabihin, H1 is 0, H2 is 0. So therefore, the right side of the equation will be 0. At the same time, the beams will be prismatic throughout its span. So, kumbaga, EI1 and EI2 will just be the same. So, you can simply cancel them out. So, yun yung point ko, no? And this is the general formula. You should understand this. But again, we rarely use this because of the special case. So, one of the special case that I said nga, if the entire span of the beam is prismatic, so EI1 equals EI2 is equal to EI. So here, I just remove the EI, no? This is the general formula, no? I just remove the EI because it's nonsense lang naman, no? But I just multiply it here, okay? So kung titingnan nyo, mas malinis, no? Mas magandang tingnan itong equation natin. So MAL1 plus 2MB L1 plus L2 plus MCL2 plus 6AAB centroid ng A over L1. Again, this is the constant that we are going to discuss later on sa discussion. Then plus 6ABC centroid ng C over L2. So that is equal to 6EI. So again, the quantity H1 over L1 plus H2 over L2. Kasi ang ginawa lang dito, I just cross-multiply that to the right side of the equation. But anyway, yun na nga. Ito yung mangyayari kapag constant yung EI. So this will be the working equation. As I explained earlier, the sign convention of H1 and H2, kapag sila ay nasa taas sa middle point, they are positive. Yung sign convention ng mga moment, I will discuss that in the next video kapag nag-solve na tayo ng mga problems. Okay? So next tayo, another special case. So what if, yun na nga, wala talagang deviation? Because most likely, ganito ang mangyayari. All supports, kasi the three-moment equation specifically used sa mga continuous beam, and ang usually hinahanap is the moment at the interior span or interior supports. And syempre, part of the theoretical approach natin sa analysis, walang displacement dito, dito or dito. So, ibig sabihin, they are just on the same level. So, as I said, kapag ganun yung mangyayari, let's go back to the original formula. You will just substitute H1 and H2 equals 0, cancelled out. So, ito lang yung formula. Okay? And lastly, the simplest among them is ito. So, if span ABC have a constant EI, at the same time, same level pa. Okay, no? So, prismatic na nga, tapos magkaka-level pa yung support. So, ayan na, naging mas malinis yung formula. So, throughout our discussion in the structural theory, I will just use either this third equation or the fourth equation. Simply because I don't want to make this complicated na. In reality, leveled naman talaga ang mga supports. Although, I'm not sure, maybe your own prof can give you mind-blowing problems na kung saan may displacement yung support. So that is according na rin dito sa second formula. Okay, but since this is simply an introductory part of the three-moment equation, and gamit na gamit nga ito sa continuous beam, and most continuous beam have leveled supports, I will just use the equation 3, this one, kasi i-assume natin that maybe the first one is or has different EI compared to the second one, no? Why compared to this one? Okay, so I think we are now ready to the part 2 of this video. So the next part kasi, as I said earlier, one of the major concerns in the three-moment equation is kung paano natin hahanapin yung mga values ng mga constants na ito. So I will not torture you to memorize again the tables from Python and Singer in the strength of materials. Instead, I will give you three formulas. One of them is of course integration kapag involved na yung mga distributed load. So katulad sa fixed end moment, one formula sa concentrated force, one formula for the concentrated moment, and one formula which is integration for the distributed force. And let's start with the discussion, no? So, as I said, ito siya yung constant. So, for the concentrated load, ang mangyayari, let's say meron tayong P, tapos ito yung span A and yung span B. So, the distance from point A is small a, and the distance of point B is the small b. So, here, ang nangyari, importante class na proper yung pagkasulat nyo, especially yung subscript ng X bar. Yun yung isa sa pinaka-importante sa pagsusulat ng three-moment equation. Maraming estudyante ang nagkakamali sa three-moment equation simply because they improperly wrote that. So, yun no, ulitin ko from the 'di ba, 6AAB centroid, palaging A kasi yun yung left end ng span natin, and dito naman yung C yung rightmost end. Okay? So, importante kasi yan because kapag naging letter B to, iba yung value niyan. Okay? Kaya nga dito, may dalawang formula ako because of course, magagamit mo rin sila later on. So, this is the generalized approach, but I have two formulas here. So, yung formula ng 6AAB, centroid ng A over L, is equal to PA over L and the quantity L squared minus A squared. Sa libro ni Python, ito yung formulang makikita nyo. Well, of course, kapag nagbago lang yung centroid, di ba, same span, sorry no, pag nagbago lang yung edge na i-consider natin instead of point A, we consider point B. So, yung A, mapapalitan lang ng B. Okay? Of course, before I solve a problem, let me derive this formula. So, actually, the three-moment equation class or ito is simply, this is simply a formula. Kaya lang, yun na nga, instead of, ang original na process kasi talaga dito is, mag-i-sketch ka ng moment diagram by parts, and pagka-sketch mo ng moment diagram by parts, gagamitin mo itong eksaktong formula na to. So, 6 times yung area ng moment diagram between AB multiplied by their centroid with respect sa point A, then divided by L. So, yun talaga yung meaning ng formula na yan. But, again, hindi na yun advisable because sketching alone the moment diagram by parts each span is a complicated and a lengthy process. So, we just rely on the formulas. So, let's derive na lang, no? So, derivation tayo ng formula na yan. So, i-assume natin na yung span AB natin class is simply supported. Ganun naman talaga ang mangyayari dyan. So, the span AB is simply supported. And let's place the support P here. So, this is P. And let's say, ito yung distance A and ito yung distance B. Of course, there will be reactions here. So, dito, ang magiging reaction dito, class, ay PA over L. While on the other hand, this will be PB over L. I will let you investigate na lang no, using statics. Hindi na ako doon masyadong magpapakahirap sa sarili ko. So, by simple statics, malalaman nyo naman na yan yung magiging reaction on both sides. Okay? So, kapag na-sketch na natin, ang next step is again nga, since moment diagram by parts yung original na approach talaga dito is i-sketch mo by moment diagram by parts, then gagamitin mo yung exact formula. So, mag-general formula na lang tayo. So, kung maalala nyo, yung moment diagram, halimbawa ito, sa point na ito, syempre, ang mangyayari, this will be downward, and nandito siya ngayon, this will be PA because 'di ba no, concentrated load P times A that is equal to PA. So, shade nga natin. On the other hand, dito tayo sa PAL, then multiply mo siya ng L. So, therefore, ang mangyayari dyan, PA over L multiply by L, sorry, that is simply PA. Okay? So, we have two triangles, both of them have a height of PA. So, ang ang patutunayan ko lang dito in this derivation is the first one because once I derive this or once I illustrate the derivation of this one, kayo na bahala dito sa pangalawa. Okay? So, again, ano nga yung ano natin formula? 6 area ng AB, centroid at A all over L. As I said, ang ibig sabihin lang naman nito ay 6 divide mo ng L, tapos yung area ng AB multiplied by the centroid by or centroid with respect sa A. Nasobra pala ako ng pag-sketch dito, no? Dito lang naman pala yung ano natin, yung PA over L. So anyway, ganito lang siya. Ayan, parehas na rin yan. So here, gagawin natin na area ng AB, starting with this positive na 1/2 ng base L. Tapos, syempre, ang height ay PA. And di ba, the center of gravity of this one is located here. That is 1/3 ng L. Okay? Then minus for this triangle. Kasi nga, di ba, intindihin nyo, parang moment area theorem lang to. Yung ibig sabihin ng area AB, centroid ng A. So, yung area naman nitong triangle na to, dahil nasa baba siya, 1/2 ng A. So, since this is A, and PA, and 1/3 A. Okay, so when we simplify this, that will be 6 over L, and that is 1 over 6 ng PA L squared minus 1 over 6 ng PA cube. Okay? So, I already simplified that. And kung mapapansin nyo, dahil may 1 over 6 siya, so makakancel lang yan and we can factor out PA on both sides of the equation. No? So, therefore, yung 6AAB, centroid ng A, over L is equal to PA over L. So, pag finactored natin yan, ang matitira dito ay L squared, while on the other hand is A squared. So, notice that this is exactly the same doon sa formula na nasulat ko. Again, if you want to prove na ito ay tama, all you need to do is to draw another moment diagram by parts and just place that here. Okay? Pero uulitin ko, I will not do that here because magiging sobrang haba na nitong discussion natin. So, let's start illustrating the formula by giving an example. So, ito, determine the value of 6AAB, centroid ng A, over L, and 6AAB, centroid ng B over L of this beam. So, let me copy here or copy that into this OneNote. So, ngayon, let's start first with beam A. Okay? So, solution tayo doon kay beam A. So, ang mangyayari, i-drawing lang natin to, no? 6 meters. So, the beam is 6 meters, A and B. By the way, no, yung derivation class, part of the derivation is i-assume natin na the span is simply supported. But in the actual process, there is no need. Kasi not necessary nga yon. So let's draw the given here. This is 50 kilonewton, and of course ito yung ating A as 4 meters and yung B as 2 meters. And syempre kung titingnan nyo naman, the total length of the beam is, or of the span, siguro the proper term here is the span, kasi hindi pa naman to yung beam. This is just part of the continuous beam. Later on mas maiintindihan nyo siya. So ayan siya. So ngayon solve natin yung 6A. Ang pagsulat, no, 6A, AB, ibig sabihin area in the span AB, then centroid with respect sa A over L. So the formula is PA over L, then L squared minus A squared. Okay, so just substitute that as 50, tapos 4 divided by 6, then 6 squared minus 4 squared. Tapos, let your calculator do its job. Ang lalabas dito, I will write that into fraction na lang. So, 2,000 over 3. The unit of this is kilonewton meter squared. So, yung unit ng constant na ito is kilonewton meter squared. Okay? So, proceed tayo to the other one, yung 6AAB, centroid ng B over L. So, that is simply PB over L, tapos the quantity L squared minus B squared. Then substitute this as 50 over 50 times 2 over 6. Then the quantity 6 squared minus 2 squared. So ang sagot natin dito is 1,600 over 3 kilonewton meter squared. So ito na yung solution natin sa unang beam. Well, of course, we need to consider the next beam. So solution tayo for the beam B. So, dalawang concentrated loads lang naman yan. So, kumbaga, addition lang naman yung mangyayari dito. So, sige, let's start drawing this. The beam is 7 meters, or sorry, again, the span is 7 meters. Dito, 80 kilonewton. On this part is 60 kilonewton. So, 2 meters, 3 meters, and 2 meters. So, this is point A and this is point B. So, I will start solving this. Una, yung 6A, AB, centroid ng A over L is yun na nga, PA over L, the quantity L squared minus A squared. So, since dalawang beams yung i-consider natin, so, unahin ko yung nandito sa 80, no? So, yung 80, yung distance niya from point A is 2 meter, then divided by 7, then 7 squared minus 2 squared, then plus, of course, the 60 kilonewton force. Its distance from point A is 5 meter divided by 7, then 7 squared minus 5 squared. So, ang sagot natin dito when you compute this using your calculator is 14,400 over 7 kilonewton meter squared. Okay? Well, on the other hand, yung 6AAB, centroid ng B over L is equal to PB over L, then the quantity L squared minus A squared. So, sorry, PL squared minus B squared. So, ang sagot natin dito ay equal sa 60 times 2. Baliktad. Unahin natin dito sa 80. Gaano siya kalayo from point B? 5 meters, then divided by 7. Tapos, 7 squared minus 5 squared. Then, of course, plus yung 60. Gaano siya kalayo sa point B? That is simply 2 meters. Then, 7. Tapos, 7 squared minus 2 squared. So, ang sagot natin dito is 15,000 divided by 7 na kilonewton meter squared, or 15,000 over 7 kilonewton meter squared. You can simply convert this na lang into decimal by using your calculators. Okay? So, I think this part illustrated the use of the formula in evaluating sa mga constants ng three-moment equation. So, tandaan nyo ito, napaka-importante ng lesson na ito because later on, once na nag-evaluate na tayo ng three-moment equations, magiging essential na ito. So next tayo, na-discuss na natin yung about sa mga concentrated force. Let's proceed to the concentrated moments. So dito class, the value of that, kung ang kino-consider natin is a clockwise moment, yung value ng 6AAB, centroid ng A over L, is equal to M over L ng L squared minus 3A squared. Then, kapag yung centroid nag-shift from A to B, ang mangyayari, medyo nakakalito dito kapag concentrated moment. So, magne-negative ito. So, always observe na since clockwise ito, so, yung about A, that is positive, yung about B, magne-negative. Okay? So, ang mangyayari, negative m over L, the quantity L squared minus 3p squared. So, kapag counterclockwise, ang nangyari lang, from here, sa clockwise na positive, naging counterclockwise siya, ay sorry, sa clockwise na positive, sa counterclockwise negative, and of course dito, from negative naging positive. But they are similar in a sense. Okay? So, you can derive this, no? Wala namang pipigil sa inyo na mag-derive niyan. But of course, para makatipid na tayo sa oras, I will now skip in derivation. I already taught you naman kung paano siya. Again, yung assumption sa derivation, yung ating span is simply supported. You determine the reactions. Tapos, this is simply a formula and you will use the moment diagram by parts. Okay? So, I will use the formula directly na lang. Let me attach this into the ano, no? OneNote. Then let's start solving this example. Okay? So, basahin ko lang yung problem. According dito, determine the value again of 6AAB, centroid ng A, over L, and 6AAB, centroid ng B, over L of the beam shown below. So, let's start with the first beam. Okay? So, solution. With the beam A, so, attach natin, medyo malaki. Hindi siya beam A, no? Pala, sorry. I am corrected. Span A. So, dahil kung titingnan nyo, clockwise moment, no? So, yung una nyong titingnan, kung ano ba yung applied moment. Is that clockwise or counterclockwise? So, here it is shown na clockwise siya. So, I will use these formulas. Okay? So, yung mga formulas na yan. So, for instance, 6 area ng AB, centroid ng A, all over L is equal to M over L, the quantity 3L squared minus A squared. So, tama ba? Ayan, no? Na-memorize ko pa pala. So, all we need to do is to substitute 65 over 6 because the total span of the beam is 6. Then, the quantity 3, yung length ng beam ay 6 squared minus 4 squared. Kasi, di ba, yung distance ng beam from point A is 4 meters. So, using your calculator, you will obtain na yung value niya is negative 130 kilonewton meter squared. Okay, so yan yung sagot natin. Meanwhile, yung other formula, 6 area AB, centroid ng B over L, so that is equal to negative M over L, then 3L squared minus B squared. So check ko nga kung tama ako. Yes, I am right. So we can substitute this as equal sa negative 65 over 6, the quantity 3 times 6 squared minus 2 squared. Okay? So here, ang magiging answer natin is negative 260 kilonewton meter squared. So ayan na, no? Meron na tayong values nitong constants na to for the span A. So how about span B? So here, The span bilang naman is simply a counterclockwise moment, di ba? So, therefore, let me copy na lang para makatipid na ako sa time mag-drawing. So, dahil counterclockwise moment siya ngayon, class, edi syempre, ang mangyayari, pag sinubstitute natin siya, yung 6 area ng AB, centroid ng A over L will be equal to negative M over L, then 3L squared minus A squared. So, pag sinubstitute nyo, negative 45 over 5 because the total span of the beam is 5 meters, no? So, 5 squared minus 3 squared, no? Because 3 meter yung distance niya doon. Parang may baliktad ako dito, no? Baliktad yung formulas ko. Sorry. I am completely wrong on my formulas. Yung 3 pala, yung nandito pala sa yung A and B pala yung naka-multiplied ng 3. Okay? So again, my mistake here, I am wrong. So palitan ko lang siya as L squared minus 3A squared. However, based doon sa computation, all of the values appeared naman ay correct. Okay? So, 6 squared minus 3 ng 4 squared dito sa una. Let me change first, no? The given formula. And ito naman, L squared minus 3B squared. So, pag in-erase ko to, so ang magiging sagot ay 6 squared minus 3 2 squared. Pero mali lang yung pagkasulat ko, pero tama pa rin itong sagot dito. Okay? So here, let me go back. Mali ito. Pero at least di pa natin siya nako-compute. So this is L squared minus 3A squared. Okay? So pag sinubstitute natin siya ngayon, that is 5 squared minus 3 ng 3 squared, di ba? Because 3 meter yung A natin. And our answer is positive 18 kilonewton meter squared, while for the other one, the last one dito sa part na ito, yung 6AAB, centroid ng B over L is equal to, syempre, M over L na ng L squared minus 3B squared. So, pag sinubstitute natin siya, that is 45 over 5. Then the quantity 5 squared minus 3 2 squared because the B is 2 meter. Ang sagot natin dito ay 117 kilonewton meter squared. Okay? So let's proceed to the last part nitong video na to, which is the computation of this constant. If the given na is the concentrated load, distributed load. So as I said earlier, kapag distributed load, the best way here is to integrate. Mas madali naman na mag-integrate dito. And the formula is WA, kapag no, centroid ng A, tingnan nyo na lang. Again, focus tayo sa centroid ng A. Kung titingnan nyo, the integral of WA over L, then the quantity L squared minus A squared, then dx. So, from 0 to L. So, yun ay naka-A. Tapos, yung nandito is naka-B naman. And, tip lang, para hindi kayo mahirapan sa pag-memorize, balik ka lang dito sa concentrated. Actually, ang ginawa lang natin dyan, instead of letter P, 'di ba? Instead of P, ginawa lang natin siya na W. And yun na nga, may kasamang ahas na integral. Parang kanina doon sa pagkukuha ng fixed end moment, 'di ba? Yung fixed end moment ng mga distributed is galing lang naman doon sa formula ng concentrated load. Tapos, pinalitan lang natin yung P ng W and nilagyan mo ng ahas. So, this is exactly the same. Because integration is simply summation of yung uniform load is assuming na summation siya ng infinitesimal amount of concentrated loads. Okay? So, ang dami ko ng term na napaka-alien na pakinggan. I think we can now attach this first. Tapos, as I said, we can solve an example para nga mas maintindihan nyo yung mga values niyan. So, let's solve this one. So for this problem, basahin ko lang. Determine the value of 6AAB centroid at A and 6AAB centroid at B of the beam of the span or of the beam span as shown below. Okay, so i-consider natin yung span A. So solution for span A. So ngayon, the beam is, or the span, sorry, is 6 meter in length. At the same time, yung uniform load natin ay 45 kilonewton per meter. So this is point A and this is point B. So let's apply a strip here. Then W is equal to 45. Ilelet ko tong A as equal sa X. 'Di ba? Okay, so or for instance, ilelet ko to as x at the same time ito syempre 6 minus x. So by the way, nakalimutan kong sabihin, katulad din sa fixed end moment, yung S represents the total length of the load. Ulitin ko, no, yung S dito represents the total length of the load. Baka kasi yung iba is nalilimot. So, iba yung L is the total length of the span, yung S is the total length of the load. Nagkataon kasi dito that our load is distributed and applied throughout the span. So, balik tayo dito. Of course, this will be our A and this will be our B. So, the formula ng 6 area AB, centroid ng A all over L is equal to the integral of WA over L then L squared minus A squared dx from 0 to S. And syempre, yung ating W is 45, yung A is X, then divided by 6, the quantity 6 squared minus X squared dx from 0 to 6 because the load nga is applied throughout the beam. So, ang sagot natin dito ay equal sa 2430. 2430 kilonewton meter squared. Okay? So, 2430 siya. Then, proceed tayo to the other one. So, yung 6AAB naman, centroid at P over L. So, yun na nga, the integral of WB. Sorry. WB over L, then L squared minus B squared dx from 0 to S. So, pag sinubstitute natin siya, that is 45. Then, 6 minus x over 6, the quantity 6 squared minus 6 minus x na naka-squared dx from 0 to 6 din because yun na nga. Actually, hindi magbabago yung limit dito. Kung ano yung in-apply mong limit sa taas, yun din sa baba. Ang exception lang, yun na nga, instead of x, naging 6 minus x. Pag kinompute nyo to, using your calculator, that is still 2430 kilonewton meter squared. I am expecting that their values are the same simply because, no, I am expecting na parehas sila ng value dahil yun na nga, the beam or the load is symmetrical. So, di ba, symmetrical naman yung load, rectangle, that is very symmetrical. So, yun na. And actually, in most cases, ito yung pinaka-common. This is one of the most common shapes of load na nakikita nyo, especially pagdating nyo sa design. Syempre lahat ng loads ina-assume na lang yun na uniformly distributed kasi mas madali sa analysis. So mabuti if i-memorize nyo na lang yung pinaka-shortcut formula na applicable lang sa mga uniform load. So yung 6 area AB, centroid ng A over L, and that is equal nga sa 6 area AB, centroid ng B over L. So, yung shortcut formula dito ay WL cube over 4. Okay? So, we can prove that, no? Kung gagamitin natin yan as 45, 6 cube over 4, and using our calculator, so, ang sagot natin ay 2430. 2430 kilonewton meter squared. So, yun, no? You can use integration because this is more versatile and ano nga, magagamit mo sa kahit anong types of load Halimbawa, kung putol, no? Halimbawa, hindi in-apply yung beam throughout the span, so i-adjust mo lang yung limits ng integral. Okay? Pero itong special formula na to, this is simply applicable kapag yung loadings ng beam natin is throughout and uniform load lang. Okay, so I hope you get my point. So here, for the next beam, o ito, I am expecting that the values will be different kapag with respect sa A and with respect sa B. So for the span B, solution ng span B, so, ina-expect nyo naman na syempre kapag triangle, there will always be a ratio and proportion. Hindi na yun mawawala. So, magre-ratio and proportion na naman tayo dito. So, since triangular load ito, and syempre this is 4 meters and 1 meter. So, 4 meters and 1 meters. And this is point A and this is point B. Let me have a strip here. Tapos, iseset natin tong strip na to as X. So, hindi na ako dito masyadong magpapakahirap because this is 40 kilonewton per meter. Na isolve na natin to doon sa fixed end moment na yung W dito ay equal sa 10x. Again, this is solved using ratio and proportion na lang, di ba? So, W is equal to 10x, mag-ratio and proportion ka na lang dito sa triangle na to. And since the total span of the beam is 5 meter, so that is 5 minus x. And syempre, ito yung ating A and ito yung ating B. So, as I said nga, mas maganda yung integration dito kasi hindi niya nire-require na dapat yung triangular load is applied throughout the span. So, dito hanggang 4 meters lang yung application niya. Okay? So, let's start solving yung 6 area AB. Centroid ng A over L is equal to the integral of WA over L, then L squared minus A squared dx from 0 to S. So, pag sinubstitute natin yan, the integral of 10x tapos x divided by, ilibaba ko because I doubt magkakasya pa siya dito. So, that is equal to the integral of 10x, then x, tapos 5 meter, the quantity 5 squared minus x squared dx. Ang limit ko lang is hanggang 4. Uulitin ko, no, kasi baka yung iba nalilito, sir, bakit 4? Kasi nga, di ba, the beam or the load lang is applied for 4 meters only. Okay? So, I hope clear tayo doon. And our answer here is 657.067 kilonewton meter squared. Okay? So, again, ang unit nito is kilonewton meter squared, no? Next tayo is 6AAB, centroid at B over L. So, actually, wala ka naman dito masyadong i-adjust sa integral nyo. With an exception of yung A, papalitan mo lang ng B. So, halimbawa, yung W is 10x, yung B ngayon is 5 minus x, yung L is 5, the quantity 5 squared, minus 5 minus x squared, dx, then the limit is from 0 to 4 pa rin. Hindi magbabago yung limit na yon. Okay? So, our answer is 622 0.933 kilonewton meter. By the way, you can pause my video for a while if you want to make sure na my answer is correct here. You can use your calculator, i-pause nyo muna tapos i-verify nyo using this answer. Pero I am certain naman na the answer nga is this one. Okay? So, ayan. Tapos na tayo sa discussion class ng paghahanap ng value nga ng mga constants na ito. Okay? So, I hope naintindihan nyo itong video na to despite the fact na napakahaba na. Kasi nga, uulitin ko, isa sa pinaka-challenging na part ng paggamit ng three-moment equation is yung paghahanap ng value ng constant because that will depend on the orientation of our loadings. Pero kapag nahanap nyo na to, magiging sobrang basic na nito. Oo, magtiwala ka. And we will illustrate that on the next video. So I will end this now. Thank you so much for listening and watching. And ingat po kayong lahat.